Hi, my name is Garima, and today we'll see how Weka is used for making two kinds of model, mainly decision tree and linear regression. Here, I've already loaded the iris dataset. The iris dataset has the target variable that is nominal, that is, it will have three categorical values: setosa, versicolor, and virginica. The other variables here are sepal length, petal length, and width, and we can see the statistics of those variables here, and we can also visualize these variables here in bar graph. We can also edit the data from this option here. We'll go to classify. We'll choose the model we want to build. We want to build a decision tree out of the values here. We choose J48. Here we can choose how do we want to use the data. Do we want to use completely as training set, or do we want to supply a test set externally and use this as training set, or do we want to use cross validation or percentage split. Suppose I give 66% here. This means that 66% of the data will be used for training and 34 will be used for testing. Now, since we are building a decision tree, we have to keep in mind that the target variable should be in nominal or categorical form. We use decision trees whenever we want to predict a categorical value, either 0 or 1, yes or no. So we build a decision tree here, and here we get the tree. We can visualize it better from visualize tree. This is the tree we've got. If we want to look at it better, we can fit it to screen, increase the size font. Yes, so as we can see, the most significant predictor which our model has taken is the petal width. It classifies on the basis of petal width. If it is less than equal to 0.6, then it predicts it to be iris setosa, or if it is greater than 0.6, then it again checks for petal width, and so on and so forth. If we look at the evaluation of the tree, this model has 96.07% of overall accuracy. These are the mean errors of the model. These show how what is the variation between the actual value and the predicted value. These are the true positive rate, false positive rate for all the three classified values: setosa, versicolor, and virginica. And here is the confusion matrix. Now, if we go through the confusion matrix, the columns are the predictions and the rows are the actual values. So, if we look at row iris virginica, we can see that out of 17 total records, 15 are predicted accurately by the model and 2 are predicted inaccurately. So 15 virginica are predicted as virginica. However, 2 records which were virginica are predicted as versicolor. Now we'll go through regression. For linear regression, the target variable should be either numeric or in continuous form. So regression models are used whenever we want to predict a target in a range. Here the data set we've taken is for predicting the heart rate of a domestic cat. So the heart rate can be from 0 to infinity. We want to see which all variables the heart rate depends upon. So we have the sex of the cat, the body weight of the cat, and the heart rate is in numeric form. Now we go to classify, we'll choose functions and linear regression, and again we choose say cross validation, and we start to build the model. Here is the model we've got, the linear regression model. So according to the model, the heart rate only depends on the body weight. This is the weighted coefficient of the body weight. So and this is the intercept of of this model. So we can see that the heart rate only depends on the body weight by this much coefficient. It doesn't depend on the sex of the cat at all. So if we want to check what the heart weight of a cat is, we just need to know the body weight, and we will be able to predict the heart rate. So this is how we build linear regression model and decision tree in Weka. Thank you.